Hello everyone, this is Noah Nichols. Today we're going to analyze and track the movement of the nine-banded armadillo using ArcMap. As armadillos move across the United States, they could cause property damage and alter the environment, so it is meaningful to see how the range may expand and shift over time. Before utilizing the ArcMap program, there was a fair amount of research which needed to be completed. While analyzing the nine-banded armadillo, I identified two main indicators which determined whether or not they could live in a particular area. Due to their limited fat deposits, current research indicates that they can live in areas which have a minimum January temperature of 28 degrees Fahrenheit or higher. Despite their relative hardiness, they also require 15 or more inches of precipitation per year to survive as well. Since another one of my goals was to track future movement based on climate change, it was also important to find out how much the planet would warm. According to the United States Environmental Protection Agency, Earth has been warming by 0.32 to 0.55 degrees Fahrenheit per decade since the late 1970s. To utilize their data quickly and efficiently in the ArcMap program, I elected to use a value which was in the upper range put forth by the US EPA. This is why my maps will be based upon the assumption that Earth will warm at about 0.5 degrees Fahrenheit per decade. Before looking at my maps, I would like to take a moment to explain how each map will be made as well as what each map is trying to accomplish. The first map will analyze temperature and precipitation as it relates to the nine-banded armadillo. It is informed by data from the National Oceanic and Atmospheric Administration. While this does not tell us anything about the armadillo yet, this information is vital for understanding why the armadillo's range may be shifting or expanding. Map 2 will be where the information from Map 1 comes into play. The data from Map 1 will be sorted into information which is meaningful to the nine-banded armadillo and its range. In essence, this map will let us visualize what areas have adequate climates for the armadillo. While the armadillo may not be in these locations yet, it will allow us to see areas where armadillos could theoretically establish themselves based upon the temperature and precipitation averages in the area. Map 3 will let us anticipate where armadillos may move in the future if the Earth continues to warm over the next 250 years. Again, this is based upon the assumption that the temperature will continue to increase at 0.5 degrees Fahrenheit per decade. Knowing this, we can analyze the maps which I created meaningfully in order to determine where the nine-banded armadillo may move next. In Map 1, we can see the temperature and precipitation data of each U.S. county. While there is nothing overly unexpected, this map provides the foundation upon which the other maps were created. Taking a closer look at the symbology will allow us to see and visualize the most important portions of this map. To start, the temperature symbology is organized into two columns. The left column is made up of cool colors and all represent January minimum temperatures below 28 degrees Fahrenheit, which would mean that these areas are too cold for armadillos to inhabit. Conversely, the right column consists of warm colors and represents January minimum temperatures above 28 degrees Fahrenheit, indicating that armadillos may inhabit these areas. Looking at the precipitation symbology, one can see that there are only two divisions. Areas with crosshatching have less than 15 inches of precipitation annually and are too dry for armadillos. On the other hand, a blank or hollow symbology indicates that there is enough precipitation in that area for armadillos to survive and establish a population. Taking a closer look at the United States, one can see that it is not too far out of the ordinary. The eastern U.S. receives adequate precipitation, while many parts of the western U.S. seem to be too dry for the nine-banded armadillo. Temperature-wise, we can see that the southern U.S. is more than warm enough for the armadillos. However, parts of the northern U.S. are not. This is unsurprising, given that armadillos largely inhabit the southeastern United States right now. While this map may have been the simplest, it was by far the most difficult to make. Combining the NOAA data with the U.S. counties layer using the attribute table was incredibly time-consuming. Since there were roughly 30,000 counties of data to input twice, this was already a tall order. What made this even more interesting was that the program would struggle to identify similarly named counties. For example, the large number of Adams or Pike counties meant that each of these data points had to be given an additional identifying feature. Despite this struggle, I feel that the data was implemented into a clear symbology which represented both temperature and precipitation as they related to the nine-banded armadillo. Up next, we can take a look at Map 2. At a quick glance, one can see that the information from the 2001 Nine-Banded Armadillo range largely fits the potential range in 2023. Interestingly, the potential range is a lot larger than I had anticipated and extends well into the northeastern portion of the United States. Zooming in on the symbology, we can see that the green area is habitable and has a January minimum temperature greater than 28 degrees Fahrenheit as well as more than 15 inches of precipitation annually. The blue areas are too cold, the red areas are too dry, and the orange areas are not ideal in either respect. You can also see that the 2001 outline is a mostly transparent gray. When looking at the map, one can notice a similar trend to what we witnessed on the first map. The 2001 outline in combination with the map representing 2023 data provides a very interesting insight into the accuracy of using temperature and precipitation alone to estimate the armadillo's potential range. Kansas is a particularly interesting state to consider, as we can notice that it is blue rather than green, and is still within the 2001 range. Otherwise, the map is largely what we would expect. Some of the most interesting aspects of this map regard the areas which were within the 2001 range but did not fit within the parameters I selected. The Texas counties which were too dry were relatively unsurprising, since the area was particularly dry this year and the data was from April 2022 to March 2023. However, Kansas is more of a mystery. It is odd to see that Kansas has been consistently too cold for years, yet it retains a population of nine-banded armadillos. My best guess is that prey is more abundant in Kansas and that they can burrow to survive the cold since it is relatively short-lived. For Ohioans like myself, this data is interesting because it implies that an armadillo population may be able to establish itself in Ohio right now. Next up, we will take a look at the third and final map. This one is the most interesting since it allows us to predict the expansion of the potential armadillo range over the next 250 years. Here's a closer look at the symbology. All of the colors except for gray represent different points at which armadillos could move to the highlighted areas. After 250 years, it seems as if armadillos in the United States would be able to attempt to establish a population in every eastern state. This part of the United States is of particular interest because we can see clear bands that represent expansion over the years. It is fascinating to see that the bands are this clear in the eastern United States but are not present at all in the western United States because of the low amounts of precipitation. As mentioned before, there is a clear northern expansion evident over the next 250 years. To the left of Ohio, we can see that Indiana, Illinois, Missouri, and Iowa could eventually be inhabited by armadillos. To the right of Ohio, we could see that New York, Vermont, New Hampshire, Massachusetts, and parts of Maine could eventually be inhabited as well. On the west coast, northern Idaho and Montana face a similar fate to California. All in all, though, this is dependent upon the nine-banded armadillo's ability to expand its range. There is no guarantee that they can make it that far or that predators in these states would not eliminate them quickly. All in all, I feel that the power of GIS was highlighted throughout this project. We were able to predict how the range may expand and where invasive populations of armadillos could establish themselves as the earth warms using this data. Right now, there are many states where armadillos are not established where they could theoretically survive. In this sense, they could be considered behind what is estimated in a way. This idea led to another question. Why aren't there armadillos established in these areas? Thinking ecologically, it is likely that there are predator-prey relationships at play. Humans also view armadillos as a pest that destroys property and spreads leprosy, so this could lead to a slowed expansion as well. Another question arose when considering Kansas. Could armadillos live through harsher winters than we anticipated? Despite these questions, it is clear that armadillos are capable of spreading to many areas as temperatures continue to rise. We may see an increase in armadillo-related issues, such as property damage as well, so it is pivotal that we continue to track the expanding range of the nine-banded armadillo. The data utilized to create the maps came from a variety of locations, including Esri, the NOAA, Armadillo Online, Sciencebase, and the US EPA. I hope that you enjoyed the presentation. Thank you for watching.